Well, I know I'm the last thing stopping you from the last thing stopping you from going home. So I'll try to be quick. What an amazing couple of days. It's been so wonderful to hear the science that everyone's working on and also just to hear a lot of the stories. And thanks for showing us so many photos of ourselves when we were half the age and half the size that we are now. So I thought I would, I'm trying to be sort of match the things that I'm hearing to some of the wonderful goals and the really aspirational, incredible vision of NASSP that has been running through the whole program. And so in my mind, I think, what are the three things that NASSP strived to and continues to do? You want to find the next generation of scientists from Africa and show them what research means. Show them what it means to be a scientist. You want to mentor and train scientists, and you want to maximize the output from cutting-edge instruments like SALT, MeerKAT, SKA, to really propel and continue to propel Africa into the next, decade, century, millennia. So I'm going to focus on those goals and how they have I realize NASSP has just infiltrated a lot of not only my research agenda, but also just my scientific passion and understanding for what it means to be a scientist. So we start with the first one, find the next generation of scientists. Well, you have, congratulations. And so my personal journey, I did a BSc at the University of Pretoria, and then I came here to do NASSP honors in 2006, which was really transformative. And I also was one of those things, I saw the poster, whoever's making the posters, don't stop making the posters. The posters are a very good idea. And then I did a master's by research with the SKA HCD program. And then I went on to the UK to do my PhD, and then to Princeton to do a postdoc. And then since 2016, I've been at the University of Toronto. And because everyone is showing the photos, I'm also part of the original group that had the bad background. So this is me. Obviously, I look exactly the same. I loved looking at these photos. I must admit, my favorite one, there's one photo of us where we look like we're in a band. It's like golden light of the group. We all have this dreamy look, but really, in reality, it was mainly this. We were smiling and laughing. And apparently, in 20 years, your outfit does not change. So I saw this photo and I was like, wow, I think I need a stylist. But I just have to make a shout out to one of the most formative experiences of my life, not even as a scientist, but as a human being, which is I got to program a robot to do what I wanted. Like, I've never felt more like I controlled the whole earth than when I got that silly little robot to turn a corner. So as someone who does not operate telescopes, I guess this was as close to glory as I was ever gonna come. But I think it's also, for me, whenever I tell people about my story, I also tell them about the back stuff that you normally don't hear about. So, my backstory is I almost didn't apply for NASSP. I had done a little bit of astronomy, but I just thought, I don't know if this is a good idea. What if I'm just stupid and I flunk out of all the classes and it doesn't make sense? So I almost didn't apply. To do my PhD in the UK, I really almost didn't apply. In fact, it was a long time ago, so you had to hand everything in by paper. And I remember I was like 20 minutes before the end of the deadline to hand in my application to get a Rhodes Scholarship, because I just thought, this is a stupid idea, don't do it. You'll never get it. So I almost didn't do that. And then when I applied to a postdoc, so you apply, if you're doing a postdoc in the Northern Hemisphere, you apply in October, and then everyone decides on the job they want by mid-February. I got an offer in February. So for January, I was the world's just most irritating person. I was super upset. I just thought, I tried really hard. I thought I was great, and no one else agrees, and what am I gonna do? And I later found out that I got the job that someone else turned down, because they put on their CV, I turned down this fellowship, and I was like, okay. But I actually really like that, because a lot of the time we show our pedigree and we say, like, we did all this great stuff, but there's 100 ways that you can get to where you are, and sometimes it has a lot of sort of trial and tribulation along the way. Then I was applying for faculty jobs, and there was this job that was at an institute that focused on building instruments, and I was like, well, okay, the Lego, that's all you could do. You definitely can't apply to an institute that does instrumentation. But the person who ran the institute reached out to me on Twitter. That's what was happening those days. And he said, I think you should apply. And I said, well, I do more like software instrumentation and big data, and I'm not sure I'm relevant. He's like, just apply. Don't don't take yourself out of the job offer and like, let us do that. Let us reject you. Don't reject yourself. I mean, he didn't actually say that, but that's what I understood. And I applied for the job, and I got the job. So at every stage, there was someone giving me a kick in the pants to say, like, do this anyway. And since that time, I've applied for certain grants and certain fellowships, and whenever I win a grant, I tell people, this is the 3rd time I've applied for this grant, or this is the 4th time I've applied for this grant, because we don't say that. We don't say, like, I failed a bunch, and here I am. And I think that's really important. So don't reject yourself. Don't reject yourself. The other thing I would say is that, a lot of the time, I've really appreciated during this meeting that people have talked about some of the struggles that they've gone through as well. And, as a small, growing, but still stable percentage of 30% of women, it was also sometimes difficult to be a scientist and be a woman, because sometimes I was giving a talk and I wore that scarf, and someone said to me, no one will listen to your science if you continue to wear bright clothing. Someone said to me, dress like you're going to a funeral, and then at least you can't offend anybody. Which, I mean, that's not a bad piece of advice. I just didn't want to do that. And so instead of doing that, I decided to kind of lean in, and someone was joking, Melanie was joking, she was like, oh yeah, you always have red hair and you're giving talks, and Jacinta was saying, you always had bright hair and bright jewelry. And I think that for me, I made that decision early on that I wanted to be myself and a scientist, and I didn't want to have to choose between them. And now I spend some time trying to talk about that. So I did a talk for a group called the Story Collider. It's sort of like public talk series, and I actually gave a speech about this, and I tell about how my students, I want to address them as scientists first and not start to tell them how they must and mustn't behave. Understanding that they may come, it may be risky, right? You have a tattoo, someone doesn't like that, maybe they have an issue with you. But be yourself, don't reject yourself, and be yourself. And that's something that has taken time, but I'm really proud that this community is really welcoming and owning of the diversity of people that we have, differences of experience and differences of what we care about. So I have to give you a tiny bit about what I care about as a scientist, and I haven't seen enough of this. There's not enough cosmology representation in these talks, but anyway, so we care about what the universe is made of. This cosmic pie never gets old. I'm trying to beat down the error bars on what we understand the universe is made of. And we have had a couple of Bayesian shout-outs, but basically, we want to figure out in the X and Y axis how much of the universe is made up of dark matter or dark energy, and I want to know that answer precisely. But there will always be some uncertainty in our measurements. Error bars are always there. And so we always will have some uncertainty, and so that's why you see whenever you have a cosmologist show you a diagram, it often has a contour on it, because that contour tells us there will be some uncertainty in our knowledge of the universe, and so one of my jobs is to make that contour as tiny as possible so that our uncertainty vanishes. And one of the ways we do that is by using these exploding stars, these type 1s supernovae, to tell us about the expansion of the universe. Now, you actually can't really see this because of the light, but this is a beautiful picture of a type 1a supernova taken with the Hubble Space Telescope, dusty, gorgeous, and you can see the supernova, in fact, is just peeking out of the bottom here. So whenever I talk about big data in terms of distance indicators like supernovae, I like to use an analogy that imagine if this image of the galaxy, imagine if I now say, okay, it's a fish, because there are more fish I can take pictures of to tell you the story. So imagine I'm trying to understand fish. That picture is like this picture. It's great. I can tell you everything about the fish. We can do the science. And that's sort of the mode that we've been in for the last 20 to 30 years. Detailed observations made with telescopes where we can get deep imaging and also spectrum, and we can really understand the supernovae. And that's wonderful, except we're building new instruments like the Rubin Observatory and SKA and Meerkat that are going to give us tons and tons of data. This is a sort of similar version to the lovely animation Michelle showed you yesterday, but the sky that we see from Chile, because Rubin will be able to scan it so frequently, it will just glitter with new things every night that are changing. And so that's amazing if you want to find lots of these supernovae, but using the fish analogy, now we have this problem. So if you don't know what problem I have yet, hold on. You have this problem. So if I want to understand the same kind of fish, I now have to figure out which of these fish are the fish I care about, and which of these fish are different kinds of fish. Because if I just average all the properties of this fish, I'm going to get my answer completely wrong. And remember, the answer that I want to get is what is the universe made of? How much dark energy is there? How much dark matter? So I have to have some statistical understanding of how to do that calculation. Luckily, we introduce Bayes, this great guy. You thought my photo of me was bad. He's dead, so it doesn't matter. So Bayesian statistics gives us a way to take our uncertainty and fold it into our answer. Another way I like to explain this concept is if I showed up today and I told you that I arrived by dragon, even though I look like I could be a wizard, you would probably not believe me. But nothing about the fact that I'm here tells you that I am not here by dragon. The only way you know I didn't arrive by dragon is because you know dragons don't exist. So you are all Bayesian scientists already. And so we use that understanding, we use some of our observations with different telescopes like Rubin to give us that probability that we have one or other kind of fish, or in this case, one or other kind of supernova. So as a NASSP student, I started doing my honors project with Bruce Bassett, and he introduced me to these concepts, and I was like shook. Because first of all, I had never done research before, but then I had never sort of understood this interplay of statistics and the science. Like I'd done mathematics and I'd done statistics as an undergrad, and I thought they were boring, and they just came alive when I thought of how we can use them to understand the cosmos. Now I'm kind of embarrassed now because this plot like broke my brain, but it's actually, now it's a little simple, but at the time I was like, I understand we can take the red points and the blue points and we can kind of separate them out in statistical space and use them to come up with averages. At the time of this NASSP project, of course, we were doing a toy example. We were doing something super simple to try and explain the method to ourselves and to others and how we would handle the data that was coming from Rubin. So this was 2006 that we were thinking of the statistics of a telescope that's about to take data, which is really exciting for me. And so these models allow us to take those ellipses and make them small while at the same time not making them wrong. Because if you just were to average all the properties, say, of that fish, to use that analogy one more time, you would get the contour here that's well away from what we know the true answer to be. In this case, it's a simulation, so we know what the true answer is. So the Bayesian approach allows us to do the analysis properly and to really come to the right answer. And I showed this in my colloquium at the SAO the other day, but it's really amazing to see, that's our first paper in that was published in 2007. I then applied it to the Sloan data in 2012, and there wasn't a lot of data, but we applied this method. And then it was recently used by the Dark Energy Survey in their main cosmological analysis. And I didn't make them do it. I'm not on the Dark Energy Survey, so it was really nice. And of course, one of the next steps is that we're now applying those same techniques to data from the Rubin Observatory. We will be when we get data, and really start thinking about the whole photons to papers pipeline. As you get old, you get interested in how things work and systems and not only the science. And so I'm not embarrassed to say that these kinds of diagrams now make me very excited. How we take the data, how we do the difference imaging, how those errors propagate, how we can build the pipelines, and then also to encourage others. Whoa, I'm way out of time. I will hurry up. We don't only do that for the supernovae, so we're also building these pipelines in to our other probes from the Rubin Observatory to try and understand this. Okay, science over. You also, as NASSPs, want to train and mentor scientists. I'm incredibly proud to have worked with a bunch of scientists. My group is called the H-Nauts. It's a cosmological joke, but thank you. I appreciate that. We have a logo. Every group needs a logo. It's very fun. These are scientists from all over the world, and I'm really proud to work with them. And I wanted to give Michelle another shout out because, of course, mentoring organizations like the Supernova Foundation take those NASSP ideals and they continue to grow them. You fund one NASSP person and you take them and give them power to do even more. And I'm really proud to be a mentor in Michelle's program under her leadership. I've also tried to do that in my own collaborations. So, for example, when I was at Princeton, I brought students from South Africa, including some NASSPs, to do just research with me over the summer. I knew that as working in America, I had a little bit more research funding, and so I could pay for these scientists to come and particularly see that African scientists, often we feel like maybe when I go to the rest of the world, I will realize that some part of my degree was bad, some part of my brain doesn't work because everyone is better than me. And I really want to show these scientists that when you come to North America, actually I'm teaching people in the cohort with me things in Python that they didn't know. And I'm really standing on my own as a scientist, because sometimes we can tell ourselves stories that aren't true. We have mentoring organizations within the university that pairs students with postdocs and postdocs with faculty, so that you can continue to talk to each other about how the other things outside of your science that can change you. I know personally I've benefited from direct mentoring from people to say yes and no to me, and to really help me, especially along as you get more and more senior, because people start giving you less and less advice when you need it more and more. I've tried to build things like workshops about imposter syndrome and how you can use other approaches like comedy to try and change the stories we tell ourselves, because I think that's one of my take-home messages, is that we tell ourselves stories that are not true. And then finally, I'm really proud to serve on the Academic Council of the Schmidt Science Fellowship. So the Schmidt Science Fellowship is an interdisciplinary postdoctoral fellowship that takes people who've studied in one area, but that have translational interests. So for example, an astronomer that wants to go and work in biology, or someone who did material science and then wants to go and work in a different field, and gives them funding, but we also mentor them. We provide one-on-one mentoring to these proto-faculty to try and encourage them and help them deal with all the scary things that come from doing a PhD in one field and then 100% going to a different field. This is also an advertisement that you and people you know should be applying for these kinds of fellowships, because people in North America know about them, and so people in North America apply to them. But the next generation of, there are lots of fantastic scientists in this program, but not enough that come from other places. So please, you feel free to speak to me about that as well. Okay, the final thing I wanted to talk about is, you want to maximize the science output of experiments. And I'm really daunted and pleased and proud and very scared. So for my sins, I'm now the spokesperson of the Dark Energy Science Collaboration attached to Rubin. So Rubin's science is split up into a lot of different subject areas, and dark energy is the biggest science area. We have 1,211 members, and according to my charge, I have overall responsibility for all the scientific, technical, organization, and financial aspects of Rubin's Dark Energy Science Collaboration, which is very scary. I wanted to say this to the NASSP organizers, because I finally appreciate how much work you did to speak to the funding agencies and convince them of your goals and partner with them, because it's really scary to be in the room with someone who is asking you how you are spending your budget and how you are doing that. And at the same time, to be motivating people to essentially volunteer their time. They can work on anything in science that they care about, and you're asking them to work on things that push Rubin forward. So it's a huge privilege. I also work with an amazing team. So this is some number of our scientists at a collaboration meeting, and it's really challenging and fascinating. And then in terms of Canada, I'm trying to help us make best use of the same amazing surveys that you are working on, and in fact are giving us, including the SKA and its precursors. So we're putting together proposals to build the Canadian Data Intensive Astrophysics Platform, or CandyApple, because I love acronyms. And CandyApple is a huge data center that we're building to help, first of all, provide archives of the data that are not in the US. So this we'll have an open archive of Rubin data long after it is provided in the US, and will also allow us to do cross-correlation science with radio surveys and other observatories. So I'm really excited about that. Okay, so my last 2 minutes, I'm sorry, you gave me a 2-minute warning like 5 minutes ago. I couldn't help, because I'm at the end, I couldn't help just thinking about this and saying, okay, great, we got an A on the exam. These 20 years, good job. But NASSP is always asking you to do more and to push yourself further. So what does the next 20 years of NASSP look like? There's incredible growth of people. There's amazing capacity, scientific capacity that's been built in Africa and in the world because of this program. But what's next? I've also been trying to listen to some of the challenges that people have been mentioning. And a couple of things, have come up. And I want us to really challenge ourselves to think, how are we supporting our students and postdocs to flourish while they're in our universities and in our programs? How are we making sure we're supporting their mental health and communicating what we have, what support we have? How are we making sure that they can financially survive and they're not worried about their bursary arriving on time? Because there are lots of stresses, I think, that we forget about when we're no longer a student. When I started my postdoc, I had to write to my boss and say, you may be paying me to relocate. I cannot buy the flight because I was a student. So I was like, I can't even get to America. And he had to write me a check and give me money for the flight. We should try to have that not happen. For those that stay in academia, how can we ensure that they're really supported? There are lots of really passionate junior researchers, and I've heard multiple times how exhausted they are because they are teaching huge course loads and they're supervising a ton of amazing, brilliant NASSP students while they're at their junior level, which means it's the most critical time for them to be doing research. So how can we support them? How can we push our universities to support them and really help lift them up so that they can, continue this amazing work? For those that leave, we've had these incredible stories of people that have left, and we've also heard that they had to do a lot of extra work to prepare themselves. How can those in academia and those who have left band together and think about what skills are needed for those NASSP graduates who choose to leave, and how can we give them some of those skills before in the program? Is there a way we can use these incredible network of people together? I also want to make sure that we continue, we don't just see a NASSP as a program inside South Africa or inside Africa, but we attract international researchers to come here. There's so many amazing things about South Africa, about Africa, and it's not just the weather. It's scientific creativity. It's not just teaching either. It's not just training the next generation. There are already incredible scientific benefits about being here. So how can we make it really easy for people to come, get their visas, stay, bring their partners? I know these are all challenging problems that everyone is working on. So believe me, I'm not trying to suggest that there's not all this energy, but I want to commend your fight because it's really important that we continue to do it. And then how can we leverage the NASSP network? Someone like me sitting in Toronto, how can I do more for this community and be more engaged? How can we make sure that these incredible people across all these fields are connected and can help each other? Because I want to be more engaged. I want to help you. I want you to help me. I want to continue this community to be brought up and lifted up because I see huge potential for NASSP to continue to transform as it already has done, and other HCD programs within South Africa and Africa. There's been such amazing gains, and I'm really excited. Invite me back for NASSP at 40. Thank you so much.